In this video, I wanted to introduce you all to GoRecord, which is kind of my ActiveRecord replacement for Go. It's still in its really early stages, but I think even as it is right now, it's actually a pretty useful tool. So you can find it at github.com/johnnyb/GoRecord. And there's, so this is, as I said, it's ActiveRecord for Go. Now there's already some object relational mappers for Go. What makes this one different is that, what I loved about ActiveRecord for Ruby on Rails is that you didn't have to say everything, because the database already has a lot of the information that you want to present. So, for example, let's say I have a table with 100 columns in it. Well, in most object relational mappers, you have to go and you have to define, okay, this column goes to this field in the struct, this column goes to this field in the struct, and that's kind of it's kind of frustrating. And every time you have a migration, you have to define the migration, and then you have to go and you have to define the mapping again in the object relational mapper. And this seems like you're doing double duty. It feels like that should be handled by the object relational mapper. In fact, in Rails, you could do something as simple. Rails was what I like to call automagical. So you could do something like this. You could do class people inherits from ActiveRecord base end, and that's all you had to do. This would automatically tell, because it's inheriting from ActiveRecord base, it would tell the system that it actually needed to go and look in the database to find the fields for this, even though you called it actually this would be class person, because the individual object is going to be a person, but it would know that the database table would be the plural form, because you usually pluralize table names because there's more than one record. So it would even know that person should be pluralized to people. And so it would do all this for you. It would go and grab the underlying structure of the database, figure out what fields are in it, and automatically do everything for you. So this is literally all you had to do to pull in a table into ActiveRecord and Ruby on Rails. So that's kind of the feel that I wanted to go for. I wanted something that was just incredibly simple, that anything that you defined in the database, you didn't have to also define here, at least to the extent possible. So that's why I came up with GoRecord. And so anyway, I'll just be following along the README here. You can read it yourself. You can go along with me. It's pretty straightforward, hopefully. So to start with, you first need to get the actual library. And so you need to make sure these ... dots are added at the end, so you actually get the command, because there's a command that goes along with this. And so we will run the command, and it's going to grab our things for us. So it's going to grab, compile, and build all the pieces. So the other thing we need to do is make sure that Go is in our path. So path equals Go that's what it is. And we may actually have to, install because you actually have to install the command itself. There we go. So, so you actually need this command down here to actually get the command itself. Otherwise, I wish that Go would automatically install the subcommands, but it doesn't. So this installs the command gorec into the bin folder in Go, so you can call it go bin. So you can see my GoRec command here. So now we need to start a program. So all good Go programs start with a module declaration. So we'll do go mod init example.com/GoRec test. That's what we'll call it. And so you can see it built the module file. So now we're going to create a main file just to get started. And so main.go. This file was accidentally created when I ran the goRec command without any arguments. As I said, this is all still pretty early stage, but nonetheless, I think it's actually pretty useful even as it is. So we'll do package main, just a very simple program, import fmt function main. We will the format package print hello. All right, so basic Go program. We'll do go build, yay, and then we'll run it. And so that's our basic program. So then what we want to do is we want to create the database. So with we're using Postgres for our database system. I actually haven't tested this on anything else, so it may not work other places. Let's see, let's shrink this window a little bit. So create DB, user Postgres, and we'll call this let's call this GoRec test as well. And because you'll see it anyway in a minute, my password for Postgres is just Postgres because it's my local. So that created the database. And so now what we want to do is we need two environment variables. The GoRecord depends on these two environment variables being set. The DB driver, and that's the driver that it should use. That's the driver that it should use to make connections with. And the other one is the actual connection string. And so that's going to be, let's see here, user equals Postgres, database equals GoRec test, password equals Postgres. Okay, so now we have the environment set, we have the database created. Now what we want to do is make a migration. So GoRec, as I said, is the command. And so we're going to give it an action of migration. Actually, you need to create the subdirectory first. So we're going to create a subdirectory called migrations. And so we're going to give an action of migration. We're going to put it in the migrations directory. And we're going to name this create people. And the name doesn't really matter, but it should be unique. So anyway, so it's gonna, didn't like that. Why I didn't like that? Let's see here. Oh, it needs to be named, not name. There you go. So now if I look in migrations, we created this new migration file. And so it has a timestamp, and then it has the name that I gave it. And the timestamp is very important because that's how it knows what order to run them in. And also that's actually how they're marked. They're marked by their timestamp. So let's go look at this. So under migrations, we have it generated this migration. And so did some imports, and then it registered this migration. And really, in a migration, you can do anything you want. So this is the identifier for the migration, and that's actually stored in the database itself to mark that it's been done. And so you get two parts of it. There's an up migration and a down migration. And so you can run any Go code you want. Usually, this is SQL code. So, for example, if you want to create a people database, people table, we can just put in this code right here. So on my connection, I'm going to execute create table people. It's going to have the ID number is a serial, which means it's going to be auto incrementing. That's going to be our primary key. And then a name and a description, which are both text. So you can see this is just straight SQL. So one of my goals here is to always use the appropriate language. In Rails, they have their own migration language, and I always thought that was kind of janky. I mean, it makes a little bit of sense if you're going between databases, but overall, you really just want to use SQL for SQL stuff and use other things for other stuff. So, and then we'll return an error, however that works. And we're not going to have a down migration. That's fine. So now in our main package, we need to add all this stuff. Okay, so we'll go over this stuff one at a time. So let's look at these imports. First, this is the main GoRec import. GitHub.com, Johnny B, GoRecord, GoRec. That is the main library. Then we have this library, the migrator library, and this handles actually doing the migrations. This will load the database driver. And the reason that we import it with an underscore is that we're not actually referencing this. It gets called from the database driver, the database system itself, but it has to be loaded. So importing it with an underscore means that we're going to pull these in. The compiler is not going to complain about a package that we're not using. We're basically using it for its init functions and its symbols that it imports. And then we're going to also load our migrations in the same way, but we have to use our own, what we called our own program, which I actually already forgot. So we'll go in our module, example.com/gorectest. So we'll go here, example.com/gorectest/migrations, and that imports all of our migrations. Again, we're not going to actually be calling this guy directly. It's actually going to be called through GoRecord, but we have to load it. So then we're going to do, this is the big magic function. And so what we're going to do is we're going to first auto connect. Okay. So auto connect basically takes those environment variables that we set up and it connects to the database and creates a global connection. We also get a local version of it here if we want it to, but it also sets that up globally. And so we can also do some error handling if we want. This is just typical error handling. And then the next thing is kind of the magic migration. So we always want to make sure that our database is up to the latest version. So what we're always going to call is this migrator.migrate registered migrations. So this import here is going to register all of our migrations. And then migrate registered migrations is going to call them. So, and it's going to return an error code, and then we're going to have our typical error handling. So this way, anytime you run this, it's going to run the migrations if they're needed. So by default, since we're not doing anything anyway, if we just run this program, it's going to do the migrations. In fact, we can go ahead and just test that. We don't need that guy anymore. So we'll do go build. Oh, are we in the right place? Yes. So that gets us a new GoRec test. We'll run it. No errors. And so now if we go into our database, what we called it? Yes, it is. You can see, so this was generated automatically by GoRecord. So if we do select star from schema migrations, you can see that it has registered that we actually did that migration. And if you look at people, you can see that it did indeed build the table as we requested. So, and now it doesn't matter, we can call this as many times as we want. It's not going to do anything because it's already run the migration. So every time it check for migration, if it hasn't run, it'll run the migrations, but if they're already there, it'll be fine. So now what we want to do is we want to integrate this with Go. So we're going to create a directory called models. We don't have to put it in a models directory, but I think it's a good a good convention that I'm stealing from Rails. So in the models directory, I'm going to add a new file. This is going to be person.go. Because remember, our classes are singular, and in this case, it's Go, so it's structs. Our structs are singular because each instance is going to be a person, but the table is plural. And GoRecord can handle that, at least to some extent. I haven't put a lot into it. You have to mainly enter in a lot of exceptions to get all the singulars to plurals working, especially for the weird cases. I've put person to people into the pluralizer in GoRec, but you probably have to add other ones if you wanted to be really tricky. But it does just the general adding s's for the base case. So anyway, so in models, we're gonna do package models because that's where we are. And then we're gonna do type person struct. All right, and so if you remember our example from ActiveRecord, this was pretty much all that was required. Okay, there's a slight addition that we require for GoRecord. So what we're doing, because Go is a statically typed language, we want to take advantage of that. We don't want to have any assignments that are not statically typed, because that's actually a huge advantage of using Go. It's not only safer, it's also faster, and we don't want to lose any of that. So what we're going to do, instead of doing weird meta tricks, we're going to use Go's generation function. So Go has a generator that is just very general purpose. So you do go generate, and it will basically run anything after that. But but the command that you run will know where in the file you ran it from. So it can do special magic. So in this case, it's going to be GoRec model person. And basically what this says is it says, generate me some code. And then it calls this function. And so GoRec model person, what that's going to do is it's going to go look in the database, find all the fields for the people table, and create a struct that has all those details in it, and create getters and setters for all those that it can use as well. So it gets the model person, and so then what it actually creates is a struct called person record. Okay, so this basically uses Go inheritance, which isn't full inheritance, but close enough for our purposes. And so we basically have a type person record here. And so this allows us to do any customizations that we want. We can add fields if we need to. If we want any fields that are not serialized to the database but are just local temporary fields, we can do all that stuff here. But all the magic is in this person record, which we're not managing. So it separates out pretty cleanly the stuff that we're managing and the stuff that GoRecord is managing. So also notice that there's no space between the slashes and the Go. That is necessary for Go to pick up on it. So that's pretty much all we need to actually get this model going. So from the command line, we will go into the models directory, and we'll do go generate, which is the standard Go generation command. And package models. Did I not save this? Forgot to save it. So we'll go generate. And so that creates this new file, person.impl.go. So this is my local implementation file. This is the generated file. So it doesn't do anything to this file, it just creates a new one, this person.impl.go. So you can tell this is actually pretty long, a lot of generated code. But again, the nice thing about it is that it's statically typed. So you can, it basically uses all of Go's speed stuff is usable. And so now, notice that it now knows what person record is because it's defined here. Also notice this little bit. This is important because this is how Go knows not to run go generate. Oh, knows not to run go generate on this because it says code generated by and has do not edit. And that's kind of a standard string in Go that the generator looks for to know, hey, don't run code generation on this guy. So anyway, so we've got person.go. So this, and if we do go build, we'll notice that we get no errors. So we are good to go. So let's look at how we would do this. So we need to import our models package into main. So we'll do main.go. We're going to import example.com, GoRecord models. Okay. Visual Studio likes to rearrange these. Who knows why? It's mad though because I'm not using models yet. So after we have this code, so we've connected, we've migrated. I should probably add a must auto connect and a must migrate to simplify some of that code. So anyway, so you can see that this is just basic Go code. So let's see if I can type it so I go a little slower. So we're gonna create a record rep colon equals models dot person new. Okay, so this is one of the generated functions. So remember we had the name field. And description. We love Bob. And then error equals rec.save. If error is not equal to nil, we'll panic. And then we'll say printf. Bob's new record ID is %d period \n, and then we'll do rec.id. All right, and so this will just insert a new record. So we'll save this. We'll go to the main, go build. App. So Visual Studio Code sometimes will auto import stuff for me and sometimes it will forget. Try that again. There we go. So, so now if we do go rec test, Bob's new record ID is 1. Run it again, his ID is 2. So you can see that it's creating these records. If I go into Postgres, we can do select star from people, and it gets back the records we created. Okay, so that's all good. We can also look for records. So we can look up a record by the ID. So let's just go get a specific record. Let's just make sure we're on record 1. So other rec. So it's models dot person. I think it's find. Yeah, person find. We're gonna find 1, and there's also an error. And then we can print information. We can print information about the record. Print f record. Actually, it's always record 1. Has a name %s, and that's going to give us other rec dot name. And then let's set it to something else. Other rec dot set name. We'll set it to foo, and then we'll save it. Other rec dot save. I think that just goes back an error. And if error is not equal to nil, panic. All right, so let's go build this again. Go build, go rec test. Rec1 has a name, Bob Smith. Now if we run it again, his name, because we set his name to foo, so if we run this again, his name is foo. Okay, and our new record IDs keep on going up and up and up. All right. So we can also add relationships. So in this case, we will create a relationship about cars. Okay. So we need a migration to create the new table. So do GoRec action migration named create cars directory migrations. All right. So that's going to create a new migration. So here's our first one, create people. Here's a new one, create cars. Okay. So it starts out with nothing implemented. As I said, this can be any Go code at all, but usually it's just it's just regular SQL code. So because you get the connection here, and so you can execute. So create table cars. Cars is going to have a ID primary key. Also note that I actually have it set up so that you can actually use UUIDs for primary keys, and maybe I'll do that in another episode because it's actually a very useful trick. Person ID is going to be a foreign key to the other table. Make of the car, the model of the car, the year of the car. Okay, and so that's going to create the table. And so all we have to do again to run this is we just need to build it and run it. Yep. Let's see here. Error declared but not used. Yep. Return error. Go build. So now when we run it, so again, it runs that migration every time. So even though it did the same stuff, it also did the migration. So if we go into our database, you can see that now we have not only the people table, we also have the cars table. And if you look at our schema migrations, you can see that we have both of these going. So anyway, so now we have the car. So now we have to create the model file. So to do that, we'll just create a new file. This is car.go. So for car.go, again, this is package models. Type car struct, and it's going to have car record. And the way that this is going to be built again is with these go generate. So go generate, go rec, model car. Okay, so we're going to do that. And now if we go back into that directory, you have to be in the directory when you do go generate. There's not a recursive generate everything for me in Go yet. But you do go generate, and now we'll get our car.impl.go, the implementation file. So it may have to go build for that to be happy. Maybe it'll just never be happy. So that creates the car structure. We can also do belongs to. We can do go generate, go rec. So you do model car action belongs to relationship person. And so this says that the car belongs to a person. And so if we look at car.impl.go, you'll notice that so you have the person ID, but we don't have anything that actually talks about people. But this relationship will add a way to access the person. So we'll do go generate again, and that will generate some additional fields. So if I do person, so this is the same person ID, But it also now has, that's the find. Maybe it's at the end. I think it is at the end actually. We'll go to the very end. There you go. Person. So if I have my car and I call person, it'll query the person to find the related person to this car. So then I can add a has many in my person. Go generate, go rec model, person, action, has many, relationship, cars. All right, so this means I can have many cars off of a person. So go generate. So now if I go into person.impl and I go to the very end, I have a cars function. And I can also build a car that has that key already set. So anyway, so we can modify our main function. So I can say, when I create this new record, I can do rec.carsBuild. I think that's what I called it. Person.impl.go. Yeah, carsBuild is what it's called. I can say car : equals rec.carsBuild, car.make equals some car make, and then car.save. Actually, that's not how it's set make. I keep on getting my conventions wrong. That's what happens when you program in too many languages. If error is not equal to nil, panic error. So you can see that, and so we will go build. Oh, wrong directory. Go build. And then we'll do go rec test. And now when we go into the database, so now when we go in the database, we do select star from people. Find that we have these 9 records, and this one that we just created should have a car hanging off of it. And indeed it does. All right. So anyway, let's see here. A few other things. You can do DB test connection string. That way, if you have different test and production databases, then you can use this for testing. You can also, in addition to using the standard DB connection string, you can also use RDS base naming. In case I just did that because a lot of people use Amazon's RDS for databases. So if you use their databases, it'll automatically generate the query string, the connection string for you, and magically connect. So anyway, that's GoRecord. That's kind of about the state it is right now. I hope to build it out in the future a little bit more, but I think for basic stuff, it actually works pretty well. I do plan on getting a query builder. I should probably show you how to do queries anyway, just in general. If I want to do a query for a specific, let's say I want to do a where clause. So let's say I want to look for a car record. I can do cars error. I can do models dot car. I always forget what it's called. Car go. It's car query simple. Yeah. Car query simple. And it basically, you just give it any sort of clause where it can be where, order by, all the above. It has arguments, and they have to follow the Go convention for arguments. But you can just do car query simple. Car query simple. And I can just say where So you can imagine it going select star from cars, and then I add the where clause. And the reason why you actually have to say where is you could also just do like an order by, but you can do a limit, you can do whatever, but you actually have to say where if that's what you want. Where make equals some car make. And in fact, I think if we wanted to parameterize this, I probably should have looked this up before I started. I think you can do it with a $1 some car make. And then I can do fmt.printf found percent %d cars with that make. And I'll just get the length of cars because it's just going to give me an array. So let's see if this works. I give myself a 50-50 chance. Go build. Direct test. We found 2 cars with that make. And if I run it again, I'll have 3. All right. So that's how you do it. That's GoRecord, and as I said, it's useful for a whole lot of stuff. ActiveRecord is fancier. I don't plan on ever getting quite as fancy as ActiveRecord. I think ActiveRecord is actually overkill in a lot of cases. I think keeping it simple and straightforward is actually the better way to go. And so I plan on keeping this pretty straightforward. Like if you want to do complex selects, just make a view. Don't try to do crazy things in GoRecord. If the database supports the crazy things, do them in the database. And so again, it follows Go conventions. We're doing functions. This is the Go convention for getters and setters. You have a set function with the name of the field, and the getter is just name. So so this is the getter. That's the setter. So that's and the really nice thing, again, since this is in Go, it's statically built, it's generated, so that means that Go can inline the crap out of it, which is one of Go's most wonderful features, is that it can inline just about anything. Additionally, there's some other things that I've built to support more webbish stuff, which we'll go into later. You can do mass model assignments if you want. But again, that's not a topic for right now. I think that's enough for today. It kind of gives you a exploration of the system itself. So anyway, thanks for joining, and I hope you have a great day.